In today's video, we're going to dive a lot deeper into writing an equation from an exponential graph. Okay, so that is what your learning target is to write an equation for exponential functions presented as graphs. So today you're going to develop methods for writing an equation from a graph. As you find ways to write equations based on a graph, you will build a deeper understanding of exponential functions. And so again, as a reminder, y is equal ab to the x. That is your equation for exponentials, where a is your initial value, also known as the y-intercept or the starting value, okay? B is the multiplier. Okay, what is happening to the initial value every single time, every single term? And so let's go ahead. Oh yeah, and here it is, right? So y or a is equal to y-intercept, starting value, initial value, and b is the multiplier. And so let's look at this together. Use the clues provided in each graph below to write an equation in y equals ab to the x form. Assume that if a graph has an asymptote, it's the x-axis. Okay, so as a reminder, the asymptote being the x-axis means that the graph will never get to or cross the x-axis. It just gets closer and closer and closer. So let's go ahead and start with this first one. Our equation is y is equal to ab to the x, where a is the starting value. So right away, we can fill in a. And what is a? It is 5. That is your y-intercept. Okay, so we at least have that done so far. Next, we need to figure out what our multiplier is. So oftentimes the easiest way to do this is create a table. Okay, I'm going to start with 0. And when x is 0, y is at 5. And right here, it's telling you when you add 1, so when x is 1, y is added 2. So we add 2 to 5. Okay, so when x is 0, y is 5. When you add 1 to x and you get x is 1, you add 2 to y. So when x is 1, y is 7. Now, don't get confused by this plus 2. When we add by a constant each time, you guys know that it's linear. However, this is obviously not a linear line. So we need to figure out what the multiplier is. And by this point, you guys should be comfortable calculating the multiplier by doing 7 divided by 5. And if you do 7 divided by 5 in your calculator, you get 1.4. And that is your multiplier. 7 divided by 5 is 1.4. So that means every constant you are multiplying it by 1.4. So that goes in this B area. And that is it. That's your equation right there from this graph. Okay, so think about it, soak it all in, pause the video if you need, and try this next example then. Y is equal to ab to the x. We know that. We also know a is the starting value, and you are given the starting value. What is your starting value? It's 40. Okay, so I'm going to plug in 40 right away. Now I need to figure out my b. So let me make a little table. They give us this point, so I'm going to put that point in my table. -1, it's at 120. When x is 0, I'm at 40. And that's all the information I'm given, which is enough. Pause the video and calculate what is the multiplier here. To find the multiplier, you have to divide backwards, right? So you're going to do 40 divided by 120. And 40 divided by 120 reduces to 1/3. So your equation is y equals 40 times 1/3 to the x power. And that is it. So each of you should at least be getting half of this correct because A is just your y-intercept. And in these two problems, you were given the y-intercept. So you only need to find B. And to find B, you divide 1x, one of these, the y value, divided by the y value for the x before. Okay, and always test it too. Test to see, is 120 times 1/3, oops, I was going to put divide, times 1/3 equal to 40? It is. So you know that the multiplier is correct. Let's look at a couple more examples. Here we have this graph to an equation. So be careful because this can be written as a linear line, but we don't want it written as a linear line. We still want it written as y is equal to ab to the x power, okay? So right away, what is our a? What is our y-intercept? And it's 18. So I'm gonna plug in 18 for a. I now need to find my b. So I'm gonna try to do a table to help me out. I've got x, y, I've got 0, 1, 2, 3, 4, all the way to 5. At 0, I'm at 18. At 5, I'm at 18. What do we think the multiplier here is? It looks like it's 18 no matter what the x value is. So again, if you need to figure out what the multiplier is, you can take one of these 18s and divide it by the term above it. So 18 divided by 18 is 1. So I can plug in 1 here. And that's how we write an exponential equation. Even though it's linear, even though this can be written as y is equal to 18 as a linear function, we want an exponential function. And that is how it is done. Let's try this next example. This example actually increases in difficulty and it's very important. So you want to make sure you understand this fully before moving on. Let me make a table. Oops, let me try to make that a little bit better. Undo, okay. Wow, I'm having some trouble. Okay, close enough. So I have my x and my y. It looks like I start at 0, 7. And my next point given is 356. Let me make some room. 1, 2, 3, 56. I need to write an equation. So I've got y is equal to ab to the x. Right away, we're given our a. What is our a? It is 7, right? Because a is our y-intercept, and that's where 7 is. However, I don't know my b. And here we're throwing a little wrench in the loop. Here, I can't just do 56 divided by 7 and call that my multiplier, because technically a multiplier is from one term to the next. I've got 7 times the multiplier gives me the first term. 7 times that multiplier gives me, or not 7, I apologize. This term multiplied by the multiplier gives us this term, and that times b gives us 56. And we need to figure out what b is. So here are the steps to doing that. I'm still going to take 56 and divide it by 7. I'm still going to do 56 divided by 7. However, is that equal to b? No, it is equal to b times b times b. And b times b times b is b cubed. That's how I'm going to find my b. Now, I need b by itself. So I'm going to do some math. 56 divided by 8 or by 7 is equal to 8. Now to undo an exponent, you need to take the cube root this time. Okay, so to undo a root, you need to root both sides, cube root both sides. Rooting gets rid of the exponent, so I'm just left with b. And the cube root of a, you can throw in your calculator if you need, is 2. That's how I get that my b is 2. So my equation is 7 times 2 to the x. So let me repeat this process real quick. I wrote out my equation and I knew 7 is my a. So I plugged that in right away. I then created a table. I was given the points 0, 7, and 356. We need to find our multiplier, which is from one term to the next term. Therefore, we're not trying to find b, which is 56 divided by 7. We're trying to find b, which would give us each term. And so we do the regular process of 56 divided by the term way above, which is 7. And this time we equaled it not just to b, but b cubed, because that's how many times we would have to multiply the multiplier to get to the third term. So that's why I'm equaling it to b cubed. Now 56 divided by 7 luckily is equal to 8. And to undo the power, we're gonna root both sides. In this case, we're not square rooting it because this is cubed. So I have to cube root both sides. If you are unsure about square rooting, cubing, you need to know this by now. So you either need to look up other YouTube videos or Google it, or you can ask for office hours and I'm happy to help you with this. But it's gonna be difficult to be successful with finding the multiplier if you do not know how to get rid of exponents. Okay, so the cube root of 8 is 2. So I plugged that into my equation and that's how I got that problem. Let's move on. So we have a situation. Let's turn it into a graph. So Errol and Sandy were working on writing an exponential equation and y is equal to ab to the x form using this graph. So we were given this graph. While trying to write the equation, Errol stated, I think a must be 10 because the y-intercept is at 10. Do you agree? Hopefully, yes, you agree. Because a is equal to the initial value, which is the y-intercept. So he's right. 10 is your y-intercept. But we still don't know what b is, he noticed. His teammate Sandy had an idea. I think that 0.0032 equals 10 b to the 5. How did she get this equation and is it valid? Pause this video and think about how did Sandy get this equation? Let's look. Well, we know 10 is our A. That's correct. We have no idea what B is, so she kept B there. Where did she get her 5 and her 0.0032? She got it from this point because we know that 5 is the X value and 0.0032 is the Y value. So all she did was plug in 5 for X and 0.0032 in for Y. And it is valid. Okay, so that's the equation we got. Given a y-intercept and any point, you can plug in that y-intercept for A. You can plug in the X and Y from the other graph you were given. And what do you think we're going to do with this information? Well, if you guessed to find what B is, you are correct. So let's move on. Oops, maybe if my computer will move on. So part C, use your calculator to help you solve 0.0032 is equal to 10 times B to the 5th power for B. And so let's go ahead and start to get B by itself. If we have this equation and we want to get B by itself, that means we need to divide both sides by 10. And if you do 0.0032 divided by 10, you will get 0.00032. 1, 2, 3, 4. Yep. Okay. And so that's what we get, equal to B to the 5th power. And now to find out what that B is, just like I did in the last problem, we're going to 5th root both sides. Since it's to the power of 5, I'm going to 5th root both sides. By 5th rooting this exponent of 5, it just becomes B equals, and this you need to know how to put in your calculator. So I'm going to do my 5th root of 0.00032, and I get the answer 0.2. So use the values of A and B to write an equation for this graph. Verify that your equation is correct. So if I know my exponential is AB to the X, I know my A is 10, and my B is 0.2 to the X power. Okay, so we used our y-intercept, we used a point, we plugged it into an equation, solved for B, that way we knew what B was in our equation. Okay, let's go ahead and try this with a new problem. So let's use their method from the previous slides to write the equation of an exponential function with an asymptote at y is equal to 0 that passes through the points 0, 5 and 4, 1,280. So using their method, okay, we are going to have y, let's see, let me make that brighter somehow. Hopefully pink will show. Y is equal to, I don't like the pink, red. Y is equal to AB to the X. A is our y-intercept, and we are given our y-intercept. When X is equal to 0, that's our y-intercept, okay? And so let's plug in 5 for A. This is what we have so far. We're given this point, and we know 4 represents X and 1280 represents Y. So I'm going to plug that in for X and Y here. I've got 1280, because that's what Y is equal to, 5 times B, which we don't know, to the X, and we know X is 4. Now that we've set up our equation, we're going to solve for B. So first step, I want to divide both sides by 5 to reduce this to 1. And if I take my calculator and do 1280 divided by 5, I get 256 is equal to B to the 4th. How do we get B by itself? Well, since it's being raised to an exponent of 4, we are going to 4th root both sides. This gets rid of the exponent, and I'm left with B. And the 4th root of 256, I'm going to put that in my calculator, and I get 4. So now I can complete my equation because I figured out what B is. y is equal to 5 because that's the y-intercept. I calculated b is 4 to the x. And that's my equation. Okay, when you're given a y-intercept, it's pretty simple. Make sure you're comfortable with this and understand this before moving on, because it's only going to get more difficult or more challenging because you won't always been given the y-intercept, and that takes care of half of the problem, right? So that's why I called it a little preview, because we'll get more into this in the next lessons. Good job.